Today we're doing section 8.4 and we're going to talk about finding the inverse matrix of any given matrix. So suppose I give you a random matrix A and the values A, B, C, and D would represent numerical values. So to find the inverse, we have to do a fraction out front, and the fraction is 1 over the product of A times D minus B times C. And then within the matrix itself, we kind of scramble it. So on the one diagonal, D and A swap places. On the other diagonals, the letters stay, but they become the opposite sign. So B and C will now become negative. So, and the idea is if I multiply A and the inverse matrix, I get the identity matrix. And the identity matrix would be 1s on the diagonal, 0s everywhere else. So let's go ahead and try one of these. So here I'm giving you this matrix A, and it says to find the inverse of A. So again, out front, I do 1 over the product of A times D, which is negative 4, minus the product of B times C, which is a negative 6. So this will give me, this will become negative 4 plus 6, so this will give me a half. And then the matrix itself, I have to swap on the diagonal. So on the one diagonal, the 4 and the negative 1, keep the signs but swap places. On the other diagonal, they stay put, but the signs change. And now what I do with that half is I distribute it into all 4 terms. So on the top row, it'll become 2, 1. On the bottom row, I'll get negative 3 halves and negative 1 half. So if I were to multiply these two matrices together, I would get the identity matrix. Final answer. So eventually the idea is I'm going to show you how to use the inverse matrix to solve a system. So here it says write the matrix equation as a system of equations. So imagine if I took this, I have one row by this one column. So I would do 4 times x minus 7 times y. And I know when I do this 2 by 2 by 2 by 1, I'm going to get a 2 by 1, which is conveniently what we have located over here. So notice when I took row 1 with column 1, that would be equal to this row 1, column 1 spot of negative 3. And then the second line, I would have 2x minus 3y equal to 1. So here we were able to take this matrix equation and set it back up as a system of equations, and we'll be able to kind of go back and forth between the two. So for our next one, we're going to kind of work backwards. So now they want you to put it in a matrix equation. So essentially we're going to have a 3 by 3. Then I'm going to have my variables of x, y, z. And it's going to be equal to the answers of 8, 10, and 9. And I need you to kind of visualize it if we worked backwards. So remember, if this column of x, y, z means it had to be matched up with the numerical values. So 2, 6, and 6. So this top row is going to be 2, 6, 6. Next line is going to be 2, 7, 6, and bottom line is going to be 2, 7, 7. So on the next slide, I'm going to show you how to actually solve this. So here's a completely different way to solve a system of equations. So we solved system of equations for quite a couple weeks now using the matrix way. So now we're going to solve the system using the inverse approach. So if I have this equation, AX equals B, let me just go back real quick. So this is our A matrix right here, this is the unknown matrix, and this is our B matrix. So if I wanted to get X by itself, there is no such thing as division within our operations. We've only talked about adding, subtracting, scaling, or multiplying. So I can't really divide both sides by A, But to kind of undo this a on the left side, I would multiply it by the inverse. And if I do that to one side, I have to multiply it to the other side. Now the order does matter, so technically the inverse has to go first, and then that B matrix would have to go second. Now for problems like this, finding the inverse of a 3 by 3 is significantly more difficult, so I will give you the inverse of a 3 by 3. So I'm giving you the inverse in that top right corner, so I'm dealing with 7/2, -1, 0, 0, 1, -1, -3, 0, 1. And based on this, I have to multiply it by that B matrix. And the B matrix was the answer. So let me go back. So the B matrix was these answers of 8, 10, 9. So I'm multiplying a 3 by 3 with a 3 by 1, so I should get a 3 by 1 for my final answer. So when I do that top row, I have 7/2 times 8, and I'm just going to kind of do my scratch work off to the side. So 7/2 times 8 will become 56/2 plus 0, and then minus 27. Now I have to get common denominators. Or actually, no, 56 divided by 2 is divisible. Let's see, so half of 5 is 2, 28, minus the 27. So in the top spot, I get 1. So now for my second row, matching up to this column, I'll get -8 plus 10 plus 0. So -8 plus 10 is 2. And for my third row, I have 0 minus 10 plus 9. So I get -1. So to kind of interpret these three answers right here in terms of the system, going back, I got 1 to -1. So to interpret this in terms of the system, I got the solution of 1 to -1, my x, y, z value. So again, it's kind of a rite of passage. You have to kind of suffer through how to solve it the first way I show you for a few weeks, and now I'm going to kind of show you different ways that are different approaches and are a little bit easier. So we're going to do some practice on solving system of equations provided you have the inverse of a 3 by 3 and finding the inverse of 2 by 2s for tomorrow.